Question number 22. Two stars are viewed with a telescope using a green filter. Okay, two stars are viewed using a green filter. From here you are viewing. Let me draw the lines between them. Okay, the images of the stars are just a result. Okay, fine. Rayleigh's criteria has been solved. What is the change, if any, to the angular separation of the images of the star? See, what is angular separation? This is your angular separation. Will this change? Okay, now if unto resolution of the images, when the green filter is replaced by a violet filter. So initially you had a green filter, now this is replaced by a violet filter. Now you see, this angle will never change. Okay, because it is something like you are seeing two objects nearby to you. Okay, now if you are seeing someone else is replaced by you, do you think the angle made by these two objects with respect to your eyes will it change? It will not change, right? As long as these two objects move farther away or move nearby, only then this will change. So therefore there is no change in the angular separation of the stars. Okay, so this is gone, this is gone. These two could be correct. Now next is resolution. What is the formula for the resolution? Formula for resolution is given by theta equal to 1.22 lambda divided by d. Okay, now this is d. What is d here? D is nothing but the diameter of the aperture. So this you are not changing. But what are you changing here? You are changing the value of lambda. How you are changing the value of lambda? You are putting some violet filter and green filter here, right? So green filter, what is green? The wavelength of green, lambda g, is larger than lambda VO here, lambda violet. Okay, because lambda violet will be 400 nanometers and definitely lambda g is much more higher over here. So as a result of this, so you are decreasing the wavelength here by replacing the green with the violet. When you are decreasing it, the value of theta also comes down. When the value of theta comes down, that means whether the object is here or much more lesser also, you are able to resolve it clearly. It means the grainy details of the image would definitely be observed if the value of theta is much resolved. So okay, much lesser. In other words, you see the resolution of the images, okay, need not be, it remains resolved, okay, over here. So you are still able to see it more clearer over here. Okay, when you replace G with violet, you are able to still see it more clearer. So as a result of it, so A is the right answer.